Hello everyone. Let's now look at worksheet 11 solutions. Question number 1. At significance level alpha equals 0.1, want to run a statistical hypothesis test to find out whether full attendance helps pop up students' exam 2 score. Be sure to follow the 5 steps, and we use the following information. Assume equal population variance. So assume equal population variance. So we have sigma 1 is about the same as sigma 2. And then we have less attendance, full attendance. I think it's the same data as the questions from worksheet 10. So we got x1 bar calculated, x2 bar calculated. We can also calculate sample standard deviation 1, S1, and sample standard deviation 2, S2. And N1 is 9, N2 is 4. Less attendance, we say that's population 1 sample info, and full attendance, the data set is population 2 sample info. And then we don't have any population standard deviation term here. That means we don't have the sigma 1, sigma 2 info. So this is sigma 1 again, sigma 1, sigma 2 unknown. So then step 1, we want to state the null and alternative hypothesis. For a 2 sample or 2 population hypothesis testing, the null is always mu1 minus mu2 equals 0. So this never change. And the value, hypothesis value is always 0 as well. So that's the null. And alternative hypothesis, we have to look at the question. So whether full attendance helps pop up students exam 2 grade. That means we want to do a test to check the claim that full attendance student get better grade, and mu1 is less attendance, mu2 is full attendance. So that means what? Mu1 is less than mu2, right? Although it's pop up, but we have to look at the population definition. So that means mu1 minus mu2 smaller than 0 based on the claim. And then after we set up a null and alternative hypothesis, we can check the critical value. So the information needed are alpha equals 0.1, whether it's one tail or two tail test, right? Is smaller than, so left tail, or we say one tail left. And then sigma 1, sigma 2, whether we assume they're the same or not, if they're the same. So if they're the same, we know we have to look at the pole. We have to look at the pole standard deviation, and then the t distribution. Degree freedom going to be 11. So n1 plus n2 minus 2. So we can draw the t distribution here. We know that's t11, and then alpha 0.1. The shaded area is 0.1. So negative t sub alpha with degree freedom 11. So we check the table. We got 1.363 is the left tail. So don't forget to add the negative sign there. That's negative 1.363. So if we want to write the rejection region, we're going to say we reject the null if the test statistic is less than negative 1.363. So the smaller than is also from here. And step 3, we want to calculate the test statistics. So the test statistic is x1 bar minus x2 bar minus mu1 minus mu2. The mu1 minus mu2 is the hypothesis value, so that's 0. So we don't have to write it out. And divided by the pole standard deviation times square root of 1 over n1 plus 1 over n2. So we can calculate that using the formula here, 22.05, plug in the test statistics, negative 1.95. So then we can make the decision, that's step 4. The test statistics, negative 1.95. We want to reject it, so we put the smaller than sign here, right? And then we put the critical value, and then we just check whether it is. It is. So we reject the null hypothesis H naught. And from the distribution, we can see the rejection region is up to this critical value negative 1.363 and negative 1.95. It's more than that, so happen to lie within the rejection region, so we reject the null. And step 5, conclusion. There is enough evidence to conclude full attendance. Helps pop-up students exam grade at alpha equals 0.1. So that's question number 1. And number 2, repeat the previous process when sigma 1 does not equal sigma 2 and test whether there is a difference between students' grade alpha equals 0.1. So degree freedom, when we don't assume it's going to be the smaller of n1 minus 1, 2 n minus 1. So degree freedom is 3. So and again, sigma 1, sigma 2 unknown. So unknown means we have to look at the t distribution. So step 1, null alternative hypothesis, difference, right? So it's that's not equal, two-tailed test now. So the critical value is based on the alpha the alpha significance level alpha, whether it's one tail or two tail, and then sigma 1, sigma 2 known, unknown, and then whether they're the same or not. So from there, sigma unknown, then we have to look at the t distribution, and then they're not the same. Degree freedom is 3, so t3, and does not equal then two-tailed test. So the rejection region less two tails, and alpha equals 0.1. So alpha divided by 2 is 0.05. So we got that critical value, the upper and lower critical value. So check the table. We got the number. So we're gonna say reject null if t, the test statistic, is larger than 2.353, or if it is smaller than negative 2.353. We can calculate the test statistic. X1 bar minus x2 bar minus 0. So don't have to write it, and divided by square root of s1 squared over n1 plus s2 squared over n2. So then we got negative 2.982, and then the decision gonna be check whether it is smaller than, because it's a negative number, we only need to compare with the negative side. So it is. We reject the null. There's enough evidence to conclude that there is a difference between students' grade at alpha equals 0.1. That's number 2. Okay, number 3. Given the information below, and the test a claim whether less attendance helps increase students' exam 2 grade alpha equals 0.01. So the information includes population standard deviation, right? So step 1, the null and alternative increase, so greater than, right? And the reason we can put greater than is mu1 represent less attendance, mu2 represent full attendance. So less attendance increase, right? The grade is higher than full attendance. So that's why we put greater than. This is red tail test. And sigma known, right? So this is sigma 1, sigma 2 known case. And the previous 2 questions are both for sigma unknown. And the critical value is going to be what? Z sub alpha, because is greater than right hand, and then right tail test, and then alpha is 0.01. So that's Z sub 0.01. We can check the normal table, 2.326. And then step 3, critical value, negative 37. So the decision, negative 37 is definitely not greater than 2.326. So we fail to reject the null. There's not enough evidence to conclude that less attendance helps increase students' exam 2 grade at alpha equals 0.01. Okay, that's question number 3, and that's all for this chapter 11 solutions. Thanks for watching.